So we should try one of these from the beginning. And if no initial conditions are given, you can always let t0 be 0 and simplify the calculations as we did in the above problem. So here is one from scratch. Find the matrix exponential e to the at for the matrix A equals 1, 0, 1, 2. And we're going to use that to solve this system of differential equations. Okay, let's get on this. Well, a squared is this matrix times itself, and that's going to be 1 times 1 plus 0 times 1, so 1. 1 times 0 plus 0 times 2, so 0. 1 times 1 plus 2 times 1, and that's 3. And 1 times 0 plus 2 times 2, and that's 4. Well, a cubed would be a squared times a, and so that's 1 times 1, 1, well, plus 0 times 2. So wait a minute, 1 times 1 plus 0 times 1, that's 1. 1 times 0 plus 0 times 2, and that's 0. 3 times 1 plus 4 times 1, and that's 7. 3 times 0 plus 4 times 2, and that's 8. And then a to the fourth is a cubed times a, and that's 1 times 1 plus 0 times 1. 1 times 0 plus 0 times 2, so this is 0. 7 times 1 plus 8 times 1, that makes this a 15. And 7 times 0 plus 8 times 2, and that makes this a 16. And so now I think we see the pattern. A to the m is 1, 0, 2 to the m minus 1, and 2 to the m, right? Like if m was 5, we'd have 1, 0, 31, 32. So we can construct our e to the at. E to the at is I plus t times this matrix plus t squared times this matrix plus t squared over 2 factorial times this matrix. That's a squared. This is a cubed, so t cubed over 3 factorial times this matrix. And finally wind up with t to the m over m factorial times this generalized matrix, etc. But now, does this simplify? And the answer is yes. Because if you multiplied this whole thing out, it's going to be, the upper left corner is 1 plus t squared over 2 factorial plus t cubed over 3 factorial. So it's going to be this in that slot. And in the slot here, we've got 0 from the identity matrix plus 0 times t plus 0 times t squared, etc. So that's always going to be 0. Here's where the complicated one is. We've got 0 in the lower left plus t 3t squared over 2 factorial plus 7t cubed over 3 factorial plus finally we wind up with t to the m over m factorial times 2 to the m minus 1. So notice, if you will, that that winds up being, because of this 2 to the m, that winds up being the sum m going from 0 to infinity of 2t to the m over m factorial minus, well, this one was an obvious one, and when you put the 1 in there we just get minus the same thing as we got here. Why that 2t to the m? Let me look through that again. Let's see, in this slot we have, oh, because we have this 2 to the m times this t to the m, and that's 2 to the m t to the m. Well, that's 2t to the m. So we do wind up with just this very thing. And then in this slot we just have the same thing as the first part here. And notice, here's the cool part, notice the e to the at therefore is e to the t here, because that's what this is. 0 here, e to the 2t minus e to the t, because that's what this is, and then e to the 2t here. So we've got our fundamental matrix.